Good day, creators. Today is the 14th of September 2020. We are going to be doing technical mathematics. The topic that is going to be part of this lesson is financial mathematics. And then we all know that this topic is part of paper 1 for technical mathematics. And it's one of the topic that learners, they can collect a lot of marks from this one because it's very simple and straightforward. And then before we can start with our lesson for today, I just want to advise grade 12s that please try to go and Google for examination guideline for technical mathematics so that you can go through it and then read the important information that that you need to know before you can go and write examination. Is very important document. All right. And then for today's lesson is financial, and let's see what we have under financial. Under content, we have financial mathematics, and this topic, like I've said, that is part of paper 1, and it could contribute 15 plus or minus 3 marks for paper 1. And then under financial mathematics, we will be looking at what? Let me just take my pen. Use a simple and compound growth and decay formula. But today you will be able to know the difference between growth and decay. Then I will explain it later. And then we have now a straight line depreciation and the depreciation on the reduced imbalance method. And the last one, of course, is the nominal and effective interest rate. So those are three concepts that we'll be dealing with for today's lesson. All right, let's just proceed. The introduction of simple and compound interest. And now I'm just going to outline the simple interest formula. And then it's very important that we understand the meaning of A, or in this case, you can see its final amount or accumulated amount or the future amount, right? That is for A. And then P stands for what? The present amount or the starting value. And then I is the interest rate in terms of percentage. And then N is the number of time periods. All right. And then let's go for compound. And now compound, when you get into compound interest, A is still the same as the simple interest, is final amount. And then P is what? Is the present amount. The money that you start depositing or investing or saving. And then I is the interest rate. And then please don't forget, my dear learners, that when we are dealing with I, from the scenario, when you take it to our formula, make sure that you always divide it with 100, right? But then you will understand when we get into questions on how are we going to treat the interest rate. And then N is the number of periods, the same number of time periods. All right. Now, but when we are into compound interest, we've got different types of compound period, right? For instance, if they say it's compounded monthly, then we're going to use 12, right? But I will explain later on how are we going to use that 12 to our formula. And then when you say compounded period, it's weekly, right? And then this one is normally compounded in terms of per annum, right? So we are referring in terms of per year, per annum, right? So now we check for instance, this one of monthly, when it say 12, we check how many months do we have in a year is 12. Hence we are having 12 there. Weekly, how many weeks do we have in a year? 52. Daily, of course, is 365. days. And then this one semi-annually or half yearly. So they sometimes use semi-annually, sometimes they use what? Half yearly. So it's 2. Why 2? We check in a year, semi-annually meaning a half of what? Half of a year, which is the first 6 months and the second 6 months. So how many 6 months do we have in a year? It's 2. Hence we're having 2 there. And then we go to quarterly, and then we have quarterly, which is 4. So quarterly, it's an interval of 3 months, right? The 3 months. So how many 3 months do we have in a year? I think it's 4. So it's 3, 6, 9, 12. So it's 4. It's 4 in terms of quarterly, right? So because the interval the interval is 3 months there. And then annually, of course, is 1, because annually we're referring to a year. Annually is 1. So then it's very important to know on how do we use this compound period, right? Because we are going to be using them time and again. So it's very, very important to know that. And then also not to forget which one is how much. For instance, monthly is how much, weekly is how much, as well as the daily and etc. So it's very important, my dear learners, that you remember all those things, all right? But they only apply on the compound interest. When you're using this formula here, this one, that's where we're going to be using those compound period, all right? Then let's go and see what we can have. We have example under simple compound interest, and then let's see the scenario that we can have. All right, now we are having a scenario there. Let me just all right. It says Sibongile invest. This person invest 4,600, right? Let me just try to write it so that it can be visible to you, the amount. All right, this person invests 4,600 for 4 years at the 10% per annum. Simple interest. Simple interest. Thereafter, she invests the accumulated amount for the another 2 years at 12% per annum compound interest. Calculate how much money money she will have saved at the end of a period of what? 6 years, right? Now, first you can see from the scenario that we are going to use what? Simple interest for the first 4 years, and thereafter the accumulated amount, the money that we are going to get after we have saved for 4 years for simple interest, then you're going to continue with that amount, and that amount is the accumulated amount. Then you're going to take that amount and calculate another 2 years, but now in a form of compound interest. And then let's see on how do we do that. First, for 4 years, then you're going to use what? The simple interest formula there. And then of course, the invested amount is the money that is present, the money that we're having right now. So it's going to be P. And the other thing that is very important, every time when you're giving a scenario, it's much better when you write the data. Meaning when you write what we have so that you can be able to see what you don't have, so that we know what are you going to calculate, right? For instance, in this formula, in this scenario, you can see that this 4,600 is our P, and then this 10% is R, and then what else? Number of N, which number of years, which is 4 years, which is N. Then it's very clear that we are calculating for the future value, the final amount, right? All right, now P is this one, and then I, we know, remember I earlier on I said we always divide with this with 100, and it's going to give us 0.10 times what? 4 years. That is for first 4 years. The compound, the simple interest. Then the answer that we're going to have is 6,440, right? And then thereafter, this person, she invests again the accumulated amount, which is what? Which is this 6,440, né? with the remaining 2 years, and then but now is now with what? with compound interest, right? Compound interest. And it's supposed to be n there, supposed to be n there, because the standard equation first, we write the standard equation before we can substitute. And then of course, P we said is the accumulated amount, which is 6,440. And then the percentage, and now it start changing. The percentage is no longer this 10%, because this 10% it was for first 4 years with what? With simple interest. Now we're having another interest now, which is 12% per annum compounded interest. Now this the hence we said is 0.12, and then to the power 2, which is a number of years, which is 2 years there. And then the answer that we're going to get is 8,078 rand 34 cents. So that is the amount that this person is going to have at the end of 6 years. All right. Now let's proceed. We have another example there. What amount must listen to this one? What amount must be invested for 2 years at the rate of 10% per annum compounded half yearly in order to receive what? In order to receive this 10,000. How much money must be invested? Meaning, how much money you must have now? How much money you must save now, which is a P. So hence, I advise that it's better to write the data and then try to write what we have from the scenario. All right. And then let's see on how do we do that, because now the money that is invested is P, and then I, which is 10% compounded half yearly. Let me just underline this one. Compounded what? Remember, earlier on we touched on the different types of compounded period. We said monthly, daily, and then we also have this one of half yearly. We said half yearly is how much? We said is 2. All right. Then we're going to, from this question, then we're going to be learning on how do we use the compound period. All right. And then we can now see, in order to receive 10,000, this is going to be your A. Then let's go. And then you write the correct formula for compound there. And then you then substitute. All right. You can see that we agreed that A is 10,000, the amount of money that we're going to be receiving after 2 years. And then P is what we are in need of. And then, of course, I. We said I, you always divide with what? With 100. So when you divide this 10 with 100, it's going to give us 0.10. Divide. So you always divide with 2. We said compounded half yearly is 2. Then now, look on how do we utilize this 2. First, we are going to divide your I with 2, and then multiply the number of years with 2. So that's how you should treat the compound period. You divide I with that compounded period. You also multiply the number of years with that. All right. And therefore, and then after simply this side, then you're going to have this. Now, because we are calculating for P, of course, we're going to divide both sides with this bracket here. And then this is what we did. And then the final answer is now is what? Is 8,227 and 2 cents. Meaning this is the amount that must be invested in order for this person after 2 years to accumulate to how much? 10,000. All right. Now let's proceed. Compounded. Let's see. All right. Now the first questions on this one. Let's see. If J wishes to have, this person is wishing to have 120,000 in 5 years' time, how much must she invest if she guaranteed a return of this 8.5% per annum compounded monthly on her investment? Can you see this one is much similar to the previous one we did? We want the money which is that must be invested now. which is P. And then this person wished to have 120,000 at the later stage, meaning after 5 years, this person wants to have this amount of money. But now she wants to know how much money she must invest now, which is P. Then let's see on how do we go about that. First, write the correct formula there, which is the compound formula or compound interest formula there. And then we then substitute the values. We, of course, A is 120,000 now, and then P, and then I. Remember, you always divide your I first with 100. Then if you divide 8,5 with 100, then it's going to give a 0,085, right? Now it's compounded what? It's compounded monthly, and we agreed that monthly is 12. Then we're going to divide I with 12 and multiply a number of years with that 12 again. All right, is how you should treat what the compound period. You divide I, you multiply number of years, right? Then from there we're going to divide both sides with this bracket there, and then this is what we did. And then you just press your calculator, everything on your calculator, then it's going to give you 70. Sorry, let me just erase this one so that we can be able to read the amount that we have calculated, which is 78,569.99. So this is the amount that this person must invest in order for this person to have 120,000 after 5 years. I hope everything is clear. And then let's go to this one. They said Tibo wishes to have 25,000 in his bank account in 5 years. The interest rate, the interest is compounded what? Semi-annually. And he invests, how much this person invests, how much? 13,760. What interest rate will he require to fulfill his wishes? Now, in this scenario, this person wished to have 25,000 into his bank account after 5 years. Now, this person invests 13,000. Now, she wants to know, or he wants to know, how much the interest will be required to fulfill his wishes. Let's see on how. If, of course, it's clear that on this one, we're going to calculate I, which is the interest rate. And then we're going to substitute. We all know that P is always smaller than A because is the money that you invest now so that it can accumulate with what? With interest. There is going to have interest. Of course, A is always bigger because now is the invested amount plus the interest, right? Hence, you can see that on this one that is 25,000 for A and then 13,760 for P. And then number of years is number of years. Of course, number of years is 5 years, right? But now is 10. So how did they obtain 10? Remember, it says compounded semi-annually, and we agreed that semi-annually is 2. And then we said we divide I with 2 and multiply the number of years with that. Hence we have 10 there. And then you are going to divide both sides with 13,760. And then from now, since we're in need of I, then we have to get rid of this exponent 10. Then by doing that, we multiply with the reciprocal, meaning we're going to multiply this 10 with 1 over 10. And then what we did on the left-hand side, we must also do on the right-hand side, okay? And then now we're having what? We're having this one. And then we divide. All right, then you then divide with this one. You transpose 1 to the right-hand side, and it's going to give us -1. Then you multiply by this to take it to percentage, which is 6.7%. Right? 6.7%. Let me check if everything is correct. Let me check. All right, let me just remove this one. And then let me verify and make sure that everything is correct. My learners, it's very important now. This what the how we substituted, and then from there we try to make I the subject there, and then let's see. All right. All right, I think everything is correct on this one, and everything is correct. Let me just proceed. All right, example, changing the interest rate, changing of the interest rate. Let's see if the interest rate changes. For instance, if you have from a scenario, you're having more than one interest rate, and then how are you going to treat that? How are we going to calculate? You can see it say the calculation involving changing the interest rate. All right, let's read from this scenario and see. It says 50,000 is deposited into a saving account. The interest rate for first 3 years of savings is 12% per annum compounded half yearly. Thereafter, the interest rate changes to 18% per annum compounded monthly. The money is left to grow for the further 4 years. Calculate the future value of the investment at the end of the 7 years saving period. And then this type of question is it might be very simple if we use timeline to solve this question, because now we have more than one interest rate. And then this is the correct formula, compound interest. Now let me just explain the second step on how did we come across on this one. First, remember 50,000 is the money that is deposited, which is the P, which is the value of P. And then now they say, for instance, if you draw a number, let's try to draw a number line, if that will be possible. Let me just try to simplify it for you. All right, I don't have any tool that will draw a very nice horizontal line, but I will try my level best. Let me just write timeline there. We said it's one. No. Everything's not coming well, but I will try to explain this question. It's very important question. 1, 2, 3. Right? You can read from the scenario. They're saying the interest rate for the first 3 years is 12%, meaning from here to this 3 years, which is T. Let me just give it a name, T3. T3. The interest rate is 12%. It's 12%. All right, is 12% for the first 3 years, and then now is compounded. What is compounded half yearly? Now let's come to the first bracket and see. Now is say 0.12, meaning this 12 you divide with 100, then it's going to give you 0.12. Then it say compounded what half yearly, and we agreed that half yearly is 2. Hence we divide this interest with 2, right? Now it said for the first 3 years, and then we said 3 times what? Compounded half yearly, which is 2. So it's 3 times 2, which is 6. So I want to explain the first bracket there. All right, that is the first bracket. First 3 years is 12% compounded half yearly. Then we divide that 12 with 100. Then it gives us 0.12. And then because it say compounded half yearly, and we said half yearly is 2, then we want to say 2 divided by 2 multiply the number of years, which is 3 years, first 3 years. And then thereafter, the interest changes to 18% per annum compounded monthly. The money is left to grow for further 4 years, meaning from here is 7 years, which is 1, 2, then we have 2, 3, and let me just extend, and 4. 1, 2, 3, 4, 5, 6, 7. All right. Now from here to the last year, the 7th year, the interest rate now is what? Is 18%. The interest rate is 18% now. So now we're going to have to include the second bracket. You can see from the second bracket that we have used the second interest rate, which is 18%, and then we divide with what? With 100 is give us 0.18. But now this interest rate is compounded what? Compounded monthly, and we said monthly is 12. Hence we divide with 12, and then 12 times the remaining years, which is 4 years. Then 12 times 4, it gives us 48. And then this is how you should do it. And then you just press everything on your calculator. Then it's going to give you this amount. Let me just erase this one. Then it's going to give you 144,935.35 cents. So that is the amount of money we have calculated. All right. And then let's proceed. Withdraw and deposit. Now, what is going to happen? What is going to happen if we have withdrawals and then deposit? If, for instance, a person is investing the money today, at the later stage is going to withdraw the money or deposit another one, then what is going to happen? On how do we calculate that? Now, let us study this scenario that we're having on the screen and see on how do we calculate that. Additional payments and withdrawals. Now, it says Brenda deposit 5,500 into saving account. 5 years later, 4,000 is added to saving account, meaning this person, Brenda deposit another 4,000 after 4 years, right? And then the interest rate for the first 3 years is 14% per annum, compounded semi-annually. And then thereafter, the interest rate changes to 12% per annum, compounded monthly. Calculate the future value of the saving at the end of the 7 year. Now you can see from this scenario, we're having a deposit again, and then also the interest rate, they differ after a certain number of years. So now, for you to be able to answer this question, you can use what you call timeline. Timeline is going to help you a lot. Timeline is what I did previously. Remember the earlier, the previous slide that we just did. I tried to draw a timeline so that you can be able to see what is happening on the scenario. Now, on this one, I think we are going to start with the timeline. It's very important, right? And now let's draw the timeline, because now the total is 7 years, right? It's 7 years. You can see it's T0 to T7, which is the last year, which is 7 year. Okay. And then this person, for first year, this person deposit what? How much? It's 5,500. And then after 4 years, 5 years rather, 5 years, this person added another 4,000. You can see from here is 1, 2, 3, 4, 5. So in this point, on this point here, this person now started to do what? To add another 4,000 into that saving account. All right. Now let's go to interest rate. Let's go to interest rate and see what is happening. They say the interest rate for first 3 years. Let's count it. 1, 2, 3. Meaning from here up to this 3 years here, the interest rate now is 14%. The interest rate is 14%. And then the other one, thereafter the interest rate changes to 12% compounded monthly. Meaning for the remaining years, now their interest rate now it become, oh sorry, let me just, all right. Now, the remaining years, which is this 1 year. Now the interest, we are having the new interest rate, which is 12%, is 12% per annum compounded monthly. All right, and then remember earlier on we touched on the a scenario when where we are having more than one interest rate, and then I hope you've learned on how do we go about it. And then for this one, let's see. First, we write the standard equation there. Actually, the mistake here is supposed to be n. This is supposed to be n. We write the standard equation first of the compound interest. Then, now I'm going to explain this first, right? Let's see on how do we do this. Now, first we agree that P is the initial amount, the amount that Brenda deposits, which is 5,000, 5,500. It's a mistake, the typing error. This 5, another 5 is not supposed to be out there. Another 5 is going to be out there. I think you can use your calculator at the end of everything. After I just explain, you can just verify the answer that I got, because we just typed 5 with a mistake there, so I just removed that 5. So the deposited amount, the initial money was 5,500, right? Not this one. Hence, I've just removed that 5. All right, now let's talk about the first bracket there. Let's talk about the first bracket. Now, we said for the first year, from here, we have to calculate the interest for the first 3 years. Why not the entire 7 years? Is because the interest rate changes. Now we first have to calculate this one for the first 3 years, because for the first 3 years we are having a specific interest rate for that years, right? Which is 14%. You can see that when you divide this 14% with 100, then it's going to give us what? It's going to give us 0.14, right? And that this interest, which is 14%, is compounded what? Semi-annually, and semi-annually is 2. Hence, they have divided with what? With a 2, and then number of years is 3 years times 2, which is 6. Then hence we're having 6 there. All right. And then let's go to another bracket there. Now from here, from this 3 year, then the interest thereafter started to change to 12% now. So we're going to take from this one for the remaining years. The remaining years is 1, 2, 3, 4. Is 4 years, the remaining years. Now let me just explain the second bracket. We said it's 12%, the new interest rate. You divide 12 with 100, it gives us 0.1. 0.12, and then it's compounded. This 12% is compounded monthly. Then we divide with 12, and then 12 times 4, it gives you 48. All right, and then you say now plus. You say plus. Why plus? Because this 4,000, it was added, it was deposited again, right? If it was withdrawal, then we were supposed to use negative there instead of positive, but because it was added, then we just say plus. Now 4,000, now we can see from 4,000 here and then up to the last year, I think it's going to be 2 years. From 4,000 is 2 years, 1, 2. And then remember the interest rate of that particular 4,000. Actually, there is a typing error. It was supposed to be 4,000, not 4 or 40,000. It's 4,000. Let me just take out that 0 there. It's 4,000. All right, and then let me explain this one. 0.12. Remember the interest rate on this year is for 12%. Then 12% divided with 100 is 0.12, and then is compounded what? Compounded monthly divided with what? With 12. And then remember from year on the 5th year to the 7th year is 2 years. So we said 2 times 12, it gives us 24. and then the amount that we are getting is 18,386.28 cents. So this is the amount that we have gained. So what we can do, my dear learners, you can just recalculate it. Just put everything on your calculator and just verify if this answer is correct, because we committed a mistake there. Instead of writing 5,500, then we said 5 with a mistake, but I tried to remove it. But I believe this is the correct answer. I believe this is the correct answer. I remember when I was putting on my calculator there, it gives me this one. So please go and recheck it. But this is how you should go about it. If you have two interest rate and then there's another money which is added, and this is how you should calculate it. Okay, and then let's proceed. Example 2, withdrawals. Brently deposit a birthday gift 14,000 into saving account in order to save up for overseas trip in 6 years time. At the end of the second year, he withdraw 2,000 from the account. How much money will he have saved at the end of the 6 years period, assuming that the interest rate for the whole saving period is 18% per annum compounded monthly? You can see this person initially invest or deposit into a saving account 14,000. At the later stage, then this person is going to withdraw. Then let's see on how do we calculate that. Now the timeline I said is very friendly and it's going to help you a lot to understand what is happening on the scenario. And then you can see first year this person deposit 14,000, and then after 2 years, from year up to year, and this person maybe he wanted money there, then he went to his savings account and withdraw 2,000, right? Maybe it was for rainy days, and he wanted money there, you see, and then now we have to calculate here on this one. Now you write the correct formula there. I don't know why I'm continuously doing this mistake. We're supposed to be n here, all right? Supposed to be n there, and then the initial amount, it was 14,000, and then let me explain the first bracket. All right, what is the interest rate that we're having from the scenario? It's 18%. It does not change. It's 18% throughout. For the whole 6 years, it's 18%, but it's compounded what? Monthly. Then hence we say 8 divided by 100 is give us 0.08. Now compounded monthly divided 12, and then number of years. How 70? What is this? 72. So we said 12 times 6 is 72, if I'm not mistaken. Yes. 6 times what? 12 is 72, meaning we're going to calculate this one from year up to the last year. All right, up to the last year, which is the 6th year. And so it's 12 times 6 minus this one. We're going to calculate from here up to here, but remember minus, because we're taking it out, which is 2,000, and the interest rate still the same, 0.08, and then compounded monthly 12. And then now we check how many years from this one to this is 1, 2, 3, 4. Then we said 4 times 12 will give us 48. Then you just press your calculator, and then now it's going to give you this amount of money, which is 19,837.70. So that is the money that Brently will get. All right, depreciation. Let's see, under depreciation. So this is the formula for depreciation. And then the straight line depreciation. If it's a straight line depreciation, it's the formula that we're using. It's similar to that one of simple interest, but now it's different in terms of the sign. Remember, we use positive instead of negative for a simple interest. Also, for depreciation, it's going to be negative there. And the value of A, P, I, and N is the same thing, does not change. And then now we're now reducing balance method. Reducing balance method, we use this one, the same as the compound interest, but now only the sign, the different terms of sign, right? And then what I like about this question or this part of the financial math, every question it will outline which method to use to calculate anything. It will specify to say the straight line method or the reducing balance method. So yours is to know the formula to use. All right. Now let's see the first example that we're having there. Now, how long will it take an investment to have in value of its depreciation at the rate of 12% per annum on a straight line method? You see, on a straight line method. Now, of course, we're going to write the straight line method formula there. And then, now for this one, it's quite challenging because now we don't know what is the value of AP, right? And then they say how long, meaning if they say how long, meaning we're in need of N. So you must have A, you must have P, but they are saying the investment to have in value is depreciation, right? Meaning the investment, the amount that we invest today is going to be is twice the future value, right? Now, hence we said this P is 2x because we don't know it, and then it's going to be half in value after a certain amount of time. Then it's going to be this one. Now, under depreciation, let me just explain that. Under depreciation, P is always bigger than A, right? Because now, under depreciation, we are talking about items which are depreciating in terms of the value, right? For instance, if you talk about a car, if you buy a car today with 10,000, after 5 years, that car is not going to be 10,000, but it's going to be less than 10,000, so that the car depreciated, right? It loses its value. So P, it will always be bigger than A because the initial amount, what is the initial price of the car? It was 10,000, but after 5 years, that car is going to cost less than that amount, right? Which is A. So that's that for depreciation. Now we are going to divide both sides with 2x there, then it's going to give us 1/2. And then, of course, remember we are in need of N, then we're going to transpose that positive one this side. And then this is what we are having there. And then we divide with negative, then we divide with 0,125, and then now it gives us 4, which is 4 years. So it's going to give us 4 years. Now, number 2, if an investment of 95,000 depreciate at 6.5% percent years per annum using the straight line depreciation, determine the value of the investment, right? Let's see on how do we do that. And then the investment of 95,000 is this one, which is P. And then you can see now the answer that we're having after that years, after 3 years, is now 76,475. You can see it's lesser than the present amount, the invested amount. Can you see that? All right. Example 2, we are still under depreciation. If a car costs 85,000, depreciate at the rate of 12% per annum for 3 years using the reducing balance method, determine the amount of car after 3 years. Let's see how much money it will cost after 3 years, this car. Which is this one, 85,000 PI is 0,12. The number of years, of course, is 3 years. And then this car, it will cost 57,925 rand 12 cent after 3 years. You can see now the price is lesser, the initial price. determine the rate of depreciation that will be used if a car depreciate from 120,000 to 63,370, 327 and 80 in a period of 5 years on reducing balance. Of course, we know this is P, and then this is going to be your A, because we said clearly that A is less than P on the depreciation. And then let's see how do we do that. And then you can see A is this one, and then P there, and then I, because now we are looking for what? Now determine the interest rate, determine the rate. Now we are in need of I, and then of course we are going to divide both sides with 120,000 there, and then the third step there, remember we want I, but now we've got exponent 3, and how do we get rid of this exponent 3? Then you're going to multiply it with the reciprocal, which is 1 over 3, and then what we did on the left hand side we must also do on the right hand side, which is 1 over 3 there, and then we are left with 1 minus I, which is this one. And please, my dear learners, before you can reach to the final answer, especially for financial mathematics, you write everything on your calculator. You can see that we're having a lot of numbers here. Please don't round off this one. You only round off at the end of everything else. All right. Now we transpose positive 1 to the left hand side. There is going to give you negative 1. Then you divide with negative there. Then it's going to give you 0.1. Now we have to take it into percentage, the rate. Then you times with 100. If you times this one with 100, then it's going to give you 19.19%. All right. Example 3, under depreciation. A company bought a new 3D wheel alignment machine for 240,000. The machine depreciate at the rate of 16% per annum to have its original value over a certain period. 1. Give the depreciation value of the machine at the end of the period. The depreciated value is half of its original. It's 120,000. Right. The machine is costing this. Right. It will depreciate to half its original. Depreciate and half of its original. Original is 240. So half of this, that is going to give us 120,000. Of course, this is going to be your P, and then this is going to be your A. Now, number 2, it says determine how long it will take the machine to depreciate to have its original value. Right? Give your answer to your nearest year. Now, the formula that we're going to use the straight line method, because now it says depreciate to have its original value. So if that is the case, then we're going to use the straight line method. Then you substitute A and your P there, and the I, of course, and then you're going to divide both sides with 240,000, which is what we're going to get. And then from there, we're going to transpose this 1 to the right hand side there. And then this is what we're going to have. Then you're going to divide with negative 0.16 so that you can see, and then the N is 3.12. Therefore, it's 3 years for the machine to depreciate. So it's 3 years for the machine to depreciate. Okay. And then effective and nominal rate. We are now into effective and nominal rate. They say the nominal rate is the rate that is coded into question. The effective rate is the equivalent annual interest rate that you will receive once compound has been taken into account. In order to compare the interest rate with the different compound period, it is often used to convert nominal rate into effective rate. So this is the formula that you're going to use to calculate whether the effective rate or whether the nominal rate, right? These two. Okay, and then of course I with EFF is then for effective interest rate, and then I with norm is nominal rate. M, the number of times a year the nominal interest rate is compounded. Now this M, it does not stand for number of years, but it stands for compound period. The compound period, not number of years. Then you're going to be learning that when you are dealing with the questions. The first question say convert the interest rate of 15% per annum compounded monthly to an effective rate. Now we have to convert this 15%, which is nominal, and then to effective now. You write the correct formula there, and then you just substitute our nominal is 12%. Now we divide with 100 is 0.15, and then now it's compounded monthly. We said monthly is 12, and look how we use that 12. So it's 12 and 12 there. So there's no number of years. It's compounded period. And then we're going to transpose in this one, the side is going to be -1. And you just press your calculator, you have 0.166. Then we take it to a rate, then you times with 100, then you give us 16.08%. That's how you should calculate that. Number 2, convert the interest rate of this, then compounded quarterly to an effective interest rate. You write the correct formula, you substitute there. Of course, compounded quarterly, we said 4, so hence we have 4 and 4 there. And then you transpose 1 that side, and then you have this, then you multiply by 100, and our interest rate now is 8.51%. Simply, example 2, effective, we're still on the effective. The annual effective rate charged a financial institution is 6.7%. Calculate the nominal interest rate. In this case, we are no longer calculating the effective interest rate, but now we are calculating nominal. Let's see how do we do that. So we will have to make this I nominal the subject of the formula there. But first we substitute effective rate 0.0667, and then 12 of course is compounded monthly. Then this is what we are having this side. Now we get rid of this exponent 12 there by multiply with the reciprocal. You can see that. Now we are having this one now. This is what we are having. Then of course we're going to, now because we want to get rid of this fraction, you can see we have a fraction there. Then we're going to multiply each term with the denominator of that fraction, which is 12. Then hence we say 1 times 12 is 12, and then this one times 12, then is say we are left with I nominal, and then this one with 12 will give us this. Then of course we're going to transpose that 12 to the left hand side, and then this is going to be this, the minus 12, then it's going to give us 0.065, etc. And then you're going to multiply this one with what? With 100, and then it's going to give us 6.5%. So that is the nominal interest rate. All right, thank you very much for being with me on this lesson. It was a very interesting one. And then you can now have this activity for practicing, and then see if you can be able to answer everything. Thank you very much. And then, my dear learners, this is the message for you for today's lesson, which says our greatest weakness lies in giving up. The most certain way to succeed is always try just one more time. I thank you. Have a nice day.